for the first time, we were starting to see technologies come to life that you saw, in movies, both from a UI UX perspective, but from an intelligence perspective.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. So, I'm at a loss. Words fall flat trying to introduce today's guest. By the end of this episode, you'll understand what I mean because he's left his mark on so many industries. So here's my best shot at an intro. Today's guest, Ben Lamm, has worked to integrate AI into the largest aerospace, infrastructure, and defense institutions. He's founded a mobile game company. He's changed the paradigm for satellite constellation software, and he's even working on bringing back woolly mammoths from extinction. Ben Lamm is a technologist who is actively turning science fiction into reality. Ben, thanks for being here. You've already done more than what most people have done in a lifetime. What keeps you going, and why keep pushing into so many areas?
Yeah, well, I don't know if I've done more than most folks have done. I have this incredible desire to continue to build things, and then I have an immense desire to work with people that are much smarter than me in new and emerging fields. And so I think that I just have this rampant curiosity where I constantly want to learn new fields. I'm massively obsessed with sci-fi movies and with technology and whatever the latest trend is that's coming out. And so I find myself constantly addicted to what's next and what is that art of the possible. What's interesting is people have said well, you were in e-learning and you were in gaming, you're in mobile, you put satellites in space, now you're in synthetic biology. How does this all fit? And the only true answer is that, I don't think it does, except that there's core, system thinking and engineering beliefs that I have. And I just try to go partner with the best subject matter experts in these various categories to go build, what I think could be an interesting company solving interesting problems. And so I've just always been passionate about, how could we, deliver on the future we were all promised. And how can we, do that through science and technology? And I've just been very lucky to partner with much smarter, designers and engineers, and now computational biologists and geneticists, to hopefully help and play my part in delivering on that future.
As you look back at the different companies and projects that you've led, is there anything you're personally fond of or that stands out in your mind?
Yeah, I would say that I've been fortunate to build a handful of companies in different sectors, as I mentioned, from e-learning to gaming to mobile to conversational intelligence to space and defense, and now obviously to genetics. But I'd say some of the biggest goals that I've had hit that have got me even more passionate about the future are some that weren't necessarily tied to a company fundraising or a company milestone like an exit or growth milestone. It's some of the great R&D work. I'm insanely passionate about research and development. And what's interesting is one of my previous companies, Catholic Moon, was mostly known for our mobile application work. But one of the most exciting work that I think we did there was in our R&D lab, which was just an absolute money loss. It didn't make any money, but it was important because it allowed us to understand how we as users were interfacing with new types of technologies, kind of at the birth of the IoT movement. And one of the technologies that we worked on was biometric tattoos, and how can we start to look at modifying existing technologies and apply and connect sensors to the bodies and then those sensors to mobile devices so that you wouldn't have to, do as many adjustments to people, and we thought there's lots of interesting applications for like military and combat zones all the way to children, where if you could take, temperature and salinity and heart rate and all these different vitals, and then, and people could just kind of have this wearable moment that could then transmit data to a device like a phone or a tablet. We thought that was pre Apple Watch and, some of the most recent sensor devices that have come out. And so that was a pretty interesting project that we were excited. We were finishing it right when we got acquired by Accenture, and and so Accenture was more interested in the core business and wasn't as excited about some of those things. And then fast forward to Hypergiant. One of the most exciting projects that we worked on was actually a photobioreactor and leveraging artificial intelligence and robotics to make algae production more efficient for the purpose of carbon sequestration. And so that was something that I was incredibly passionate about because we were leveraging our software and hardware skills at Hypergiant to develop technologies that, while they weren't directly in space and defense, we thought that tangentially over time they would be, especially as you look at different types of life support systems, not just on station, but potentially off world. Obviously, my most recent initiative with Colossal has been probably my um, I'm most passionate about it because it's combining software, hardware, biology to create a Arctic elephant species that can be also leveraged to combat climate change. So it's kind of like tackling emerging tech, it's tackling sci-fi, it's tackling biology and genetics, which I think is the future and incredibly interesting. And it's also tackling, leveraging hardware and software in order to do it at the scale we want to truly impact climate change.
I definitely want to talk about bioengineering, but first I'm curious to hear more about the novel things you've been doing with AI. Until earlier this year, you were the CEO of Hypergiant. Can you tell us more about that and what made it special?
Yeah, so Hypergiant is a great company. It's now ran and led by CEO Mike Betzer that focuses on critical infrastructure, space, and defense, all through the lens of AI. And so, when I started the company, our goal was, if you look at the things that really keep the lights on for the world, so things like power, power plants, energy grids, defense of those systems, and then space that kind of helps both the communication and data flow. Those are kind of like the core plumbing, if you will, that keeps everything turning. And if you look at, when AI, started, AI, as isn't new, but when it started to get more and more traction, what we saw is all of these, folks doing programmatic ads, programmatic music, doing all these different kind of things, which were interesting. And I understand why brands want to get behind it, but we weren't seeing enough companies that were focusing on hard logistical supply chain and energy grid distribution and fail safes and then also how can we get satellites to operate like your Tesla, instead of just pushing an update once a year. How can you have this continuous delivery, continuous integration, this software approach to hardware, even in space, right? And so it's all about pushing smart IoT to the next level. And so we started Hypergiant with the goal of just doing that, going to solve really hard problems, and then over time, build platforms that could be helpful for data scientists and others to help democratize AI for others. And the company's got a couple hundred people at this point and working on some really cool projects. The last big project that I worked on there before stepping down was reconfigurable satellites. So how do we apply? How do you make the Tesla of satellites so that you have compartmentalized software that's containerized, that meets all the security standards of the DoD, but you can roll changes forward or backward so that if you have truly software enabled satellite systems, you could add a lot of different sensors to your constellation. And day one, your satellite constellation could be a communication satellite, but day two, you could make it an image satellite constellation. And so instead of having to continually put new satellites up there with different functionality and continually crowd the space, what if you had smarter systems to do that? And so those are the types of problems that we worked on at Hypergiant. Obviously we do a lot of work with Department of Defense and Air Force and Space Force and Army. So I can't talk about everything that we do, but those are the types of problems that we were solving. Is how do we bring AI and compute to the edge? How do we do it in a smart way? And even the ultimate edge with LEO and or low Earth orbit and beyond. So that was that. It's a very engineering heavy company that we started, and it's continuing to get great traction.
Are there any innovations or moments that you're especially proud of as in your time with that company?
Outside the bioreactor, which I talked about, another interesting project that I thought was pretty great was we worked on an active display system for a next gen heads up display. One that was passive that we did as a demo for NASA. One that was active where you're actually pushing frames through the lens, and it was a completely sealed system, more of like the quote unquote Predator helmet. That was Project Orion. And so looking at how do you create, technologies that first responders, police, military could all use that could potentially save lives. And and the inspiration for that was that was a project that ended up getting some government funding behind. But the whole concept was, why can't you see all these things in movies and TV shows and video games, and it just doesn't work like that.
Yeah.
And they just don't have the best UI UX and user experience. They don't have the latest kind of standards like your iPhone or Tesla for updating. There's all these things that you kind of wish it kind of worked the way when you peek behind the covers and the curtain, and you see this like system that doesn't work exactly the way you, I guess, envision it based on growing up with movies and video games and the internet. Looking for opportunities to help make those things a reality were interesting. So the heads-up display work that we did, that was all based on a neural net, was pretty fascinating, because for the first time we were starting to see technologies come to life that you saw, in movies, both from a UI UX perspective, but from an intelligence perspective. And so those were probably my two favorite projects outside of our reconfigurable satellite systems that I worked on. That was I thought was just pretty awesome.
Did your time at a video game company influence how you looked at or approached AI?
Yeah, I think partially, for me, I just think we just continually saw systems getting smarter, whether it was, a non-playable character in a video game that you were trying to create you're trying to make it smart enough, right? So that you could create an emotional attachment to the user. Those are hard problems. Those aren't just like scripted answers, right? Those aren't just like you do this, the animation plays X animation, right? So the ability to create kind of these unique experiences, and then taking those unique experiences and applying those to smarter and smarter systems, I thought was pretty interesting. And we saw this even in mobile outside of games. When we were working at Chaotic Moon with folks like Pizza Hut, their goals were, how do we not just make an app that's more efficient at selling pizza, but how do we make an app that, it's something that's very, very easy for the user, and and then how do we create systems that also surprise and delight? And so we actually built a pretty incredible concept table for them. That's a fully interactive table that was kind of an homage to the old school Pizza Hut tables, where you'd go in and I don't know if you went to the old school like 80s Pizza Hut like I did, where they actually had like Pac-Man and you could like eat on the table and you could actually play Pac-Man. So we did some stuff like that. And I think that kind of we saw corporations starting to blend AI and go beyond gaming. And that just kind of inspired me to say, okay, if we can do it at Pizza Hut and we can do it in, a mobile app, we need to be doing it on the energy grid and in more interesting areas.
So what do engineers miss or misunderstand about AI? It seems like it's kind of getting thrown around and into lots of products these days. What should engineers and implementers be aware of?
Well, it's not magic. That's the number one thing that we try to preach to people at my previous companies, and I continue to preach is it's not magic. It's just work, right? And so, like any system, you get out of it what you put in. If you put garbage data in, you're going to get bad results out. And my hope for AI is that people really move beyond the science experiment stage. I feel like there was a lot of hype around it. People got very excited about it. And then people would do these like they'd go hire one of the big consulting firms to do it. And then they would spend, tens of millions of dollars, and then they wouldn't see an ROI on that. And so then you got people then moving from kind of this, early adoption, but didn't get quite the goals from a business perspective and a KPI perspective, to then move into science experiments. And so my biggest thing is that the data scientists are like the cool kids of the future. And those data scientists, coupled with great engineering, coupled with a designer that can actually then make it real, is really important. So I think my biggest advice is that, helping companies and the organizations that people are in move from experiment into production and move from science experiment actually into production is key. And it can be with one model. It can be with one use case. You don't have to boil the ocean here and have a system that does everything. We're not, no one's looking to kind of build, or not, I think most people aren't looking to build those types of systems. So just having those things, having those wins for AI move into production, I think is really, really key. And that's something that I'd like to see. But I'd also like to continue to see kind of the convergence of data science, engineering, and design. Because when I was some of the work that we've done for some of the top generals in Space Force is when you talk to them about AI and whatnot, they get excited to a point, but then part of them, their eyes roll over because they're like, at the end of the day, they still need their team not doing low cognitive functions. They need them doing high cognitive functions. And part of that is if you can then present that data, because remember, AI is happening in the back, in the database and on the systems. They're not happening at the UI level. So you've got to make sure that in all your AI systems, you're bringing a fresh perspective to the user interface of it. Because if you make the system better and smarter, but you don't present the data in the right way, or you don't have the interaction layer with user-centered design in the right way, well, then the magic that you built is lost on that end user. And so I think that we need to make sure that we continue to index the amount of user-centered design that needs to go hand in hand with AI, in my opinion.
We'll be back in a moment with Ben Lamm. This episode is sponsored by the Passion for Technology podcast from EBV Electronic. Listen in to their latest episode discussing UV LEDs. The market for UV LEDs is currently facing a real boom, and their latest episode talks about the possibilities offered by UVA LEDs and puts the spotlight on their use in industrial applications with guests Anton Sonneveld from Broadcom and Dr. Dieter Gross from EBV Electronic. Listen now at www.ebv.com. And we're back with Ben Lamm. Ben, it's a pretty drastic shift in focus to go from leading an AI company to bringing back an extinct species. How in the world did that come about?
Right after I launched Hypergiant, I just kept reading more and more climate studies. And as we were working on the EOS bioreactor project, I just got more and more obsessed with just reading the latest trends, trying to understand where it was going. But I also, got really passionate about loss of biodiversity because I felt that everyone was talking about carbon and, what it's going to do to the atmosphere and the tipping point. People weren't talking a lot about methane suppression. People weren't talking about, the fact that we're going to lose up to 50% of all species between now and 2050. And, we were talking about the economic issues for the world. We were talking about the issues as it relates to potential financial impact, but there was this unspoken voice of all of these species that we're losing at an incredible rate. And so I thought, well, maybe there's an opportunity to leverage synthetic biology, software and hardware, in great engineering talents around species preservation. And that led me to George. And so this is the first time that I've really put the mission at the forefront of the company with all of the technologies and whatnot as kind of a secondary cause.
And this is Harvard geneticist George Church. Can you tell us a little more about him?
I mean, if you don't know George, he's probably one of the most fascinating. He's the head of Harvard Genomics and the head of the Church Lab, and he's been a pioneer in CRISPR and some of these other technologies. If you haven't read or listened to Code Breakers, I think that just the race to CRISPR in editing and advancements in single and multiplex editing is just a fascinating story. There's scandal and excitement and there's all kinds of stuff in it. So it's been a pretty fascinating world to learn about. But even before that, some of George's most recent or most earliest experiments with him and another geneticist actually showed up in Michael Crichton's first version of Jurassic Park, which I find just incredibly. A lot of people say or ask us, we get the question all the time, were you guys inspired by the books? And in a weird way, I think there was a co-inspiration there between George and Michael, which is also super interesting.
You mentioned Jurassic Park, so now I have to ask. I'm sure people bring it up all the time, But how does our culture's familiarity with that horror story of genetic modification gone wrong impact the very real work that you're doing?
Well, I think that the good and the bad is I think that the good is it at least opened people's minds to the power of genetics and the art of the possible, right? The bad is it shows you what things can, we're not working on anything like Jurassic Park, but it shows you how bad things can go, when there's even just a couple bad apples in the system, right? And so for us, that was a story in a movie about people doing things in extreme secrecy, right? And we're trying to go the opposite route. So we believe in radical transparency. We're constantly engaging with the public. We're constantly engaging with top scientific advisors, conservationists. We've got a bioethicist on staff. George has a bioethicist in his lab. So instead of going out in a lab and doing things in secret, our goal is, we took a risk and we came out and told the world what we were doing, and we were very open about it. And we got a lot of really great positive feedback. We got some negative feedback, but I think you can learn a lot from the negativity of that movie and that franchise. But I think you can also learn a negativity of the ideas that it conjures in other people. So I think it's really important to listen more to the naysayers and the negativity that comes from that, because then one, you either hopefully have already hedged against that, and you're able to communicate and inform why you're not making that decision or whatnot. Or secondly, you find new risk areas that are important to inform you to do things better. And so our goal, like while it does come up, the Jurassic Park reference does come up quite a bit, we're not focused on carnivores and the things that Jurassic Park was focused on. We're focused really on species preservation. And while people love to talk about the mammoth and the excitement about the mammoth, not enough conversations really happening around loss of biodiversity and the elephants. And so if you look at the Asian elephants, which are endangered, and you look at the African elephants and others, like there is a chance that the elephant lineage in megafauna could completely disappear in our lifetimes. And that's terrifying, right? And so there's a lot of negativity that comes from that outside of just the loss of these incredible these incredible creatures. And so if we have the ability to leverage genetic tools from and their ancestral traits to then return them to their ancestral domain, that will also have a potential impact on climate. But we're really putting elephants back in an area where there's not a lot of human elephant conflict. Northern Siberia and northern Alaska and Canada and the Arctic region isn't the most populated lands of the world and don't have the deepest population density. Then we almost have this concept that we're calling species extension, right? Where it's like, how can we use these genetic tools to put species back into locations that they used to be able to thrive in, that they can't currently thrive in? And then what lessons can we take from that to apply to other species for conservation and protecting biodiversity? And so that's a very different premise than the Jurassic Park movies, right? Like they just wanted to build big, scary things. We're going a very different route, right?
So what's next? What is that route?
What we found is that everyone seems to have a really strong opinion on the next animal, and there's a lot of crowd favorites. But I think what you'll see us focusing on outside the mammoth over time is species that kind of look like the mammoth, not from a phenotype perspective and like the physical attributes, but ones that can, how can we check the box of helping an existing species and help with conservation with an existing species like the rhinos or the elephants? How can we then, leverage genetic tools to give them the adaptation to live in an area where there's not conflict between humans in that species? And then if there's an opportunity to then, rewild a certain ecosystem because of that, we think that's pretty valuable. And so we have kind of these core tenets that we're looking at as we look through the lens of de-extinction. I don't think we should all get crazy and do all kinds of things. We really need to have a utility and a purpose behind what we're doing.
What about the mammoth? I said mammoth. I feel like that's a phrase you've probably intentionally not used. What about the elephant mammoth makes it a premier first animal for you to go after versus something that's maybe smaller or better understood genetically, like a mouse?
It's a great question. And we are working in mice. And so mouse models are a part of our study and work here. And by the way, to clarify, I have always said from day one, even before we launched, I just say woolly mammoth over and over and over again. The more scientists I'm around, the more, there's a little bit of osmosis that happens, right? Like you learn from them, they learn from you. There's kind of that mind meld that occurs. And so we like to say functional mammoths or Arctic elephants because if you look genetically at an Asian elephant, it's 99.6% a mammoth today. And so it's already genetically pretty close, to a mammoth. It's also the closest phylogenetic relative on the family tree. And so we are combining genes from woolly mammoth genomes into that of an Asian elephant cell line. And so we're creating a hybrid. And so like my grandmother, who I love dearly, if she sees our first calves, she's going to say, "Oh my gosh, it's a woolly mammoth," right? And it is a functional woolly mammoth. It'll exhibit all of the functional phenotypes that make it cold tolerant, like the small ears, the shaggy coat, the curved tusk, all of the things that we know and love, at least what we believe a woolly mammoth to look like based on what we've found in the permafrost and then artist renditions over the years. So for us, I don't mind saying it's a mammoth because it is a mammoth. It's exuding the traits of a mammoth, but it's not like we are taking the genome and the DNA in from a true synthetic biology perspective, rewriting a 100% genetically intact mammoth. It is a hybrid species, just like most species are on this planet. And so the reason why we like to use Arctic elephants or functional mammoths is because we just want to be transparent with people and let people know that, if you want to call it a woolly mammoth, I call it a woolly mammoth. That's great. If you want to call it an Arctic elephant, that's great. It's going to look like a mammoth and function like a mammoth. But just from a peer-reviewed scientific perspective, genetically, it will be a combination of those things. And so the reason why, but I know that wasn't your core question. The reason why we are really focusing on the mammoth first is a couple reasons. Number one, we can. We have a close enough a genetic relative. We understand enough about the genome, and we understand what traits make up the cold tolerance based on the work that George has done, over the last decade. So that's the first piece. The second piece is we were able to get the DNA, right, and so we don't have to go, do computer modeling and whatnot to go back in time to try to guess what those traits look like, right? We actually have the DNA from excavated from the permafrost. The third is that we have a species, being the elephant family and lineage, that is in danger, and we have an opportunity to help them. And then the fourth is also elephants in a lot of the in their current environments, plus cold tolerant elephants in the form of mammoths, mastodons, and others, are very effective at uprooting trees, at uprooting shrubs, at long migration patterns and packing the snow. There's been a lot of interesting work done by a couple of scientists like Sergei and Nikita Zimov at Pleistocene Park in Russia, who have had multiple decades really studying the ecology of the area and understanding what Arctic rewilding looks like. And so the concept of rewilding, of returning a natural habitat back to a previous state by reintroducing certain species and keystone species, like they did in Yellowstone with the wolves, has been a pretty interesting concept for conservation, especially in the last 20 years. And so the idea of introducing mammoths back into the Arctic tundra for the purpose of protecting elephants and also helping rewild that area back to it's one of its more natural habitats before a lot of the cold tolerant megafauna left that area or was killed and hunted off, is something that we're really, really passionate about. So the fact that we can, the fact that it helps elephants, and the fact that we think it'll have an impact on methane suppression in the Arctic kind of checks a lot of the boxes. And so if we work on other species in the future, we kind of want to make sure that we're checking the same types of boxes. But we are working with mouse and pig models as well.
It seems a little counterintuitive that to reduce methane production, you would introduce another large mammal.
Yeah, there's been a lot of really interesting studies. And so, like, back to also why you picked the mammoth, is that they're a large species and it's easy to roll back any unintended consequences. If you do a genetically modified bird or insect or whatnot, that's kind of a hard bell to unring. These are not small animals. So in the event that we have unintended consequences, we can at least be thoughtful and they're unrewilding, right? And so we have optionality with them, which is great. What's interesting is there's been a lot of studies specifically done in the Arctic where there is just a ton of trapped methane and carbon, and methane's about 30 times worse than carbon when it gets released into the atmosphere, and it can cause runaway greenhouse effects like what we've seen in what NASA and others have observed on Venus. And so carbon's an issue, but methane's also a bigger, almost scarier issue. And so the idea of keeping the Arctic permafrost cooler is a good thing for methane suppression. And so the studies that have been done of if there's a way to increase the Arctic grasslands and get rid of some of the coniferous forests that are there, that's a potential positive for keeping the permafrost cold, because you have the albedo effect with grass versus trees, meaning the light reflection. You've also got much better carbon sequestering. You've got much better CO2 removal. And so there's a lot of benefits to grasses versus trees, specifically in the Arctic regions, just because the trees are very, very different there than what you would think of in the rainforest. We're not against trees. We're just pro Arctic grasslands. We think you should do both in different parts of the world. And elephants are natural disruptors to environments. They love to traverse long distances. They go in big herds. They trample. It's crazy. But even a 7-year-old, 6-year-old elephant starts knocking down trees. They just love it. They absolutely love it. And so if you just Google the videos, it's crazy. And so they're not even looking necessarily for the foliage at the top of the trees. They just absolutely love it. And there's been all these studies about how the ground is cooler in areas where there's elephants because of how they stampede, how they pack the ground, and that's also similar to the ice in the tundra. So you get a lot of positive climate impacts of like removing these trees, letting the grasslands flourish, the packing of the snow by doing mammoths, and we're in the process of modeling some of this out, but we're talking about thousands of mammoths for a million square kilometers. We're not talking about hundreds of millions of mammoths to make what we think could be an interesting and important impact. So focusing on the air, there's been a lot of great studies out there in geographic studies as well as thermal and others that can really start to look at where the biggest pockets of stored methane, right? And so if we're thoughtful in those rewilding aspects, and we build the right migratory patterns with our mammoths, then I think that we don't have to cover the entire mammoth steppe or the entire Arctic region. We only have to cover certain pockets. And so I think that we can be pretty smart about that, just leveraging some of the latest ecological and satellite technology.
Okay. So can you give us the geek's guide to how CRISPR works and kind of what the recipe is for building a mammoth?
Yeah, so there's no magic recipe. We CRISPR and by the way, CRISPR is just one of the technologies that we're leveraging, but we're leveraging a bunch of different technologies as it relates to making edits at the gene level. And so we're going in and we're actually cutting different pieces of DNA and then placing in sometimes bigger, sometimes smaller blocks of DNA into a genome, into various regions of the genome that will then hopefully express the traits that we're looking for, the phenotypical traits that we're looking for. And so we're pretty thoughtful, and in terms of there's about 45 genes on the low side, and on the high side, there's about 60 genes, and we can continue to add to that with kind of our Mammoth 2.0s and beyond, talking from a software engineering perspective. So for future generations of mammoths or Arctic elephants, we can continue to make modifications and continue to add to that. But there's about 45 to 60 genes that exude the cold tolerance that we're looking for. Those are things like the small ears, a fat layer around the body, actually how they regulate hemoglobin, in oxygen at sub 30 plus and sub 40 temperatures. And then obviously the woolly hair, which is actually a consistency about 5 different types of hairs. That gives it kind of that natural woolly and shaggy coat. So what George and the team has done a great job of over the years is identifying those individual genes, isolating them, testing them with functional assays and others to understand, do they exude the output trait that we're looking for and the phenotype that we're looking for. And then now we're going into the process of actually making the edits where we're using some of these technologies like CRISPR and others to go in and make different edits and then place in and kind of fill the gaps. To your comment or to your question earlier, that is one of the good things that came from the movie. Everyone saw Mr. DNA, right? And he kind of explained how gene editing worked at the highest level that a lot of people can understand. And that's just what we're doing. But we're not doing anything weird like, what you saw in the movie where we're introducing other DNA like frog DNA and others. We're leveraging just the mammoth genomes and genes into an Asian elephant cell line.
Is it hard to get a hold of mammoth DNA?
Yeah, it's not. It is definitely not the typical supply chain. But remember, once we have the data in the computers, we kind of know what it is. It's not like we have to. It's not like we're, taking an injection of blood and then inserting it somewhere else. Where once the sequences are done and it's all in the computer, the computational biologist can kind of fill in those holes, leveraging kind of what the individual letters, what's needed. So it's actually it's actually easier than you think because you don't need now from a population genetics perspective, our goal is to have rewilded, fully interbreedable species. So we don't want to just a bunch of clones of the same mammoth because if we do that, well then you're gonna run into what they had with Wrangell Island and you're gonna have inbreeding and you're gonna lose the whole line. And so for us, more tissue and more sequencing helps us understand population genetics so that we can get to and introduce that, genetically into different embryos so that we can actually have interbreedable herds. But yeah, there's actually a ton of it out there. All the countries, even if you're working on things like rhinos or non-extinct species, all the countries own the genetic biodiversity of their area. So you've got to go through federal and regulatory processes and documentation to get the transfer of materials. And sometimes it's interesting because sometimes some of the best materials for a species aren't even in the country. So some of the best materials, for example, the thylacine, which is the Tasmanian tiger, aren't even in Australia. They're in the UK in a museum, preserved in a museum. So it's super fascinating. The ancient DNA world is a super fascinating world that I've gotten pretty entrenched in over the last year.
I bet you never thought you would know so much about elephants.
Yeah, it's crazy.
Throughout today, you've mentioned building great teams and working with great people. Could you, for me, build a theoretical dream team that could go after whatever problem pops up next, not necessarily knowing what that is specifically?
So I'm a big engineering person, right? And so I am not an engineer. Like I studied finance and accounting in college, and I know enough to be dangerous. I know enough to know if an engineer is BSing me, which I think is a pretty valuable skill set, at least in today's world. But I would focus from I always start with engineering. It's like, because you've got to have that foundation. The next part is I think you've got to look at how do you tell that story to a customer or an end user, an important person that's a critical important person in that world. Because if you build the greatest system, but as I mentioned a second ago, it doesn't have the great user interface, then I think that's a massive fail, right? Because no one's going to adopt that system. And then you've got to put the right level of support and marketing around it, but then you've got to make sure that you give it space to grow. So I'm not a big micromanager, so I like to hire people that are smarter than me and subject matter experts, and then I'm okay with having the same conversation over and over again. Like we had a conversation this morning at Colossal, and we were really focused on this one collaborator that we're very excited about that we are going to collaborate with. But when I really just kept asking the question of what do we want from that person and what are the dependents we got from that person, what I found was actually 70% we want from that person, we actually can get more efficiently somewhere else. And 30% is unique to that person. So we should just have them focus on that. So I try to listen to the engineers and in the case of Colossal, the computational biologists and the geneticists to try to understand their problem sets and then give them that support. And so for me, I don't think one team, there isn't necessarily a dream team that would, be one size fits all. I think it's really just about trying to, whatever you're going to go tackle, try to bring in the best and smartest people, regardless of their excitements, their egos, their character flaws, like we all have, and then just listening to them, right? And so I feel like 90% of my job is just trying to listen to these really smart people and then help them get what they need, and then help them get with other, and then kind of be that communication buffer with other smart people that may have different communication styles. And so I don't know if there's a magic dream team, but I think it for me, it always starts with engineering. And so like I will tell you, there's no science gates on bringing back the mammoth. There's engineering challenges as it relates to doing it at the scale that we want with artificial wombs. And so there's no real science gates there. Most of the science has been solved. There's just really strong, if you want to have 10,000 mammoths or Arctic elephants, there are engineering challenges, to that, because you don't want to do that all through surrogacy, right? That would take an insane amount of time. It's could be disruptive to the current animal population. And so I'm attracted to things that have engineering challenges. So I would always default to having an engineer first on my team, followed quickly by, design.
Nautilus Magazine seems like a bit of maybe a passion project for you, but it's a little different than a traditional like science journal. Can you tell me a little bit about it and what you love about it?
Yeah, I feel like it's I love National Geographic, but I feel like it's the highbrow science version of National Geographic. It's like if you had a purist science perspective with long form content. I was a subscriber and a fan of the content that it created in the magazine. And then, it like a lot of, it was structured as a nonprofit, and sometimes nonprofits get into trouble. And I had a great group of folks. Josh Jones Dilworth was the main one that called me and said, will you invest in it and help us, give it the infrastructure it needs to really let the editorial team be incredible at editorial. Anything that we can do that like furthers STEM education is interesting content. Like I think Nautilus is great, but it's also not for everyone, right? It's higher brow science, it's deeper, but there's a market for that. And anything that we can continue to invest and support from an education and science, I'm all about. And when that opportunity came to me, I was excited just to help where I could. But if you don't subscribe to Nautilus, I don't make any money enough from Nautilus, even though I'm a part owner. But I truly love it. And if you haven't looked at it, you should at least give it a shot.
I hadn't heard of it, and I don't know that I would call myself highbrow, but it's like this is exactly what I've been looking for in a magazine.
It's not a breaking news magazine, right? And so there's really great stuff. Oh, there's articles in there that I'm like, oh my gosh, I don't understand this, but
that's what I want.
It constantly gets you thinking, right? And that's kind of the mystery and magic of science, right? It's about the continual quest for knowledge.
And you seem like someone who's driven by that spark of curiosity.
Yeah, I look at it as like, I think of myself as like a curiosity just explorer, right? I want to explore new areas and see, like, I didn't know 2 years ago that we would be starting Colossal. I got really excited about it. I was really passionate about it. But then I thought there was, when I saw there was a way that we could pull it together in a way that could really make an impact and make it happen, I wanted to do it. But, who knows, 5 years from now, 10 years from now, maybe I'll have another crazy passion idea that I pursue. But yeah, I'm constantly wanting to learn new categories.
If you could reset and you were in a different world and you would be doing something like scooping ice cream or running a food truck, what would that be like for you?
Oh man, I've actually had this conversation because I actually am somewhat jealous of other jobs like that. I have this insatiable desire to create things. I think there's benefits to that, but there's also negativity that comes with that, like with your trade-off with, family and friends and all those things. So in another life, I would love to just, live on the beach and, be a bartender on the beach or, give surf lessons. Yeah. I can't be happy doing that in this life. There are days that I really wish that I could find fulfillment there. It's just not, It's just not how I'm wired. But that is what I would do in another life. Having a little beach bar sounds pretty great.
You've spoken about the importance of taking time for yourself and finding things that are refreshing and uplifting for you personally. What is some advice you have for folks that maybe need that window or that breath of fresh air?
Yeah, so for me, it's nature. Like I like to read, I like to go to travel, but for me, culture and nature are those two things. And even though I'm insanely plugged in I take my phone with me and my Apple Watch when I go into nature. I don't go out. I'm not like Bear Grylls in it out there. But at the end of the day, like for me, it's that. And I think you just have to find the areas to turn off your brain and relax. And that's actually pretty hard for me. The only two times I get that are one in nature. And then the second thing, I find dumb shows to watch. Like Bravo is pretty stupid. And I'm sorry to any fans of the Bravo network, but it for me is mindless television. And so I actually gave this advice on stage once when someone asked me what they could do to unwind. I was like, watch Bravo, pour a glass of wine and watch Bravo because you won't think about anything. And it's just dumb. But it's a nice dumb reset. So I'm sure I'll get some hate emails about that. But so occasionally you don't have to just watch the craziest sci-fi thing or craziest action thing that's just pumping adrenaline. So it's absolutely critical that you create that space because that's where true, at least for me, imagination comes in. And if you don't create the space for that imagination, then it just won't. For me, at least, it won't come.
In 5 words, what's next? What's sparking your curiosity today?
Birth the woolly mammoth.
Oh, that's fair. All right.
That's kind of what I bet a lot of my time and reputation and money on. So birthing the woolly mammoth is less than 5 words, and that's my focus.
Well, thanks, Ben, for your time, and best of luck with the mammoth. And thank you all for joining me today in the lobby. I somehow got through that without making an elephant in the room joke, but maybe that was the Never mind. You can find the show notes over on allaboutcircus.com. And if you enjoy this podcast, please share it with someone else you think would too. I'm Daniel Bogdanoff. It's a genuine pleasure to spend this hour with you here in the lobby, and I'll catch you next time.